Ladies and gentlemen, this is the instructional video on graphing linear inequalities on a coordinate plane. In this instructional video, you'll learn how to graph an inequality on a coordinate plane to represent all possible solutions to the inequality. The solutions will be ordered pairs. Your success criteria is you'll need to show your work, shade your solution area, and use a test point to verify your solution. Besides a notebook and a pencil, you'll need your ruler and plenty of graph paper. All right, ladies and gentlemen, I'm going to ask you to put all of these notes in your notebook. Feel free to pause, jot down these notes in your notebook. So the 5 steps that you're going to need to follow when graphing inequalities are: the first step is to solve the inequality for y. So basically we want the inequality to look like it's in slope-intercept form. Remember, that's y equals mx plus b. But in this case, we'll have an inequality. So instead of the equal sign, we'll have an inequality symbol. Less than, greater than, less than or equal to, greater than or equal to. From there, you're going to identify the slope and the y-intercept. Your third step is to graph the line using the identified slope and the y-intercept. When you're connecting the points, you'll use a dotted line if the inequality has a less than or greater than symbol, similar to an open circle if we were plotting on a number line. And you'll use a solid line for less than or equal to or greater than or equal to, similar to using a closed circle if we were plotting on a number line. Your fourth step is to select an ordered pair that's not on the line. I typically like to use the ordered pair 0, 0, as I feel like 0, 0 is an easy substitution. When I substitute it in, it's very efficient to add, subtract, multiply, and divide by 0, eliminating some common mistakes with using positive and negative numbers. So that's typically my favorite ordered pair to pick. From there, we're going to substitute.
Please excuse the interruption.
From there, we need to determine what half plane to shade. So we're going to substitute this ordered pair into the inequality and simplify. If the ordered pair simplifies to be a true inequality, we're going to shade towards the side of the line that contains the ordered pair. And if the ordered pair simplifies to be a false inequality, we're going to shade away from the ordered pair on the opposite side of the line. So we'll shade the other half plane. So we'll walk through some examples to make this shading, the idea of shading the solution set a little bit more clear. All right, ladies and gentlemen, if you don't have your graph paper out, please grab your graph paper. You're going to want to jot down this inequality on your graph paper or in your notebook. And hopefully you can see that this inequality is already solved for y, which means I'm pretty much ready to graph it. So from here, I just need to identify my slope, which is negative 2 over 1, and my y-intercept, which is negative 6. And from here, we need to begin on the y-axis at negative 6. And we are going to move by going down 2 and right 1. I can put points on the opposite side of the y-intercept by going up 2 and left 1. Okay, from here, you're going to grab your ruler. And ladies and gentlemen, I'm going to apologize right now because I do not have the technology that will allow me to draw the proper line on this recording device. So I'm not going to use a ruler, but you're going to need to in order to score a 3 or 4 on the summative assessment. I need to use a dotted line, which is why I don't have the technology on this recording device, because my inequality symbol is greater than. So if it was greater than or equal to, I would use a solid line, but because it's greater than, I need a dotted line. Okay, so here is a bad example, or a good example of why not using a ruler is not a good plan, because that line is not straight. Okay, so there is my dotted line. What I need to do from here is I need to pick a test point to determine which half plane to shade, if I need to shade above or below the line. So I'm going to select 0, 0. I think I stated before that 0, 0 is my favorite test point to pick because typically I can minimize any math errors when I'm adding, subtracting, multiplying, or dividing with 0. All right, so here's my verification. I rewrote the equation, and I'm going to use 0, 0 as my test point. I'm going to substitute 0 in for x and 0 in for y. So as I simplify, I am going to get 0 is greater than -6, which is a true inequality. What that means is the half plane that contains 0, 0, so this half plane that 0, 0 is on, is where my solution set is. So I need to grab my highlighter. Feel free to use your pencil, a pen, highlighter, whatever you have available, and shade that half plane. So anything on the opposite side, so anything below the line, would be considered not a solution. Anything in the shaded yellow region would be a solution. Here's a tip, ladies and gentlemen. When you're shading your solution set for your teacher, be very careful not to get too close or color or shade too dark close to the line so that the line isn't visible as a dotted line. So your teacher should clearly see that your line is dotted. Just be careful when you're shading so it doesn't look solid. All right, here's our next example. Go ahead and jot this down in your notebook. As you can see, this example does not have y isolated. So we're going to have to do a little bit of work here to get y by itself. So I'm going to subtract 3x on both sides, leaving me with -5y is less than or equal to -3x minus 20. To isolate y, I need to divide by 5. And just like you learned in a previous chapter, when you divide with inequalities by a negative, you need to flip the inequality symbol. So -3 over -5 is going to be +3 over +5. And then -20 divided by -5 will give me +4. Okay, so here is my inequality that I need to graph. Just because I'm running a little short of room, I'm going to put my slope up here. So my slope is 3/5, and my y-intercept is 4. So I'm going to go ahead and start plotting my points. So I'm going to begin at 4, and from there I'm going to rise 3 and run 5. I'm going to rise 3 again and run 5. And then again, to make my line accurate, I'm going to go down 3 from the y-intercept, and I'm going to go left 5. Down 3, left 5. All right, using my recording device, I can draw a solid line, which is what I need for this inequality because it is an or equal to. So my final inequality that I have to graph is greater than or equal to. So that'll be solid. I do have a solid line on my recording device. Okay, so now from here I have to determine what direction to shade. So I'm going to select a test point. Again, I'm going to go with my favorite test point right here, 0, 0. All right, I'm going to draw a line so you can see my verification. I'm going to go back to the original inequality. 3x minus 5y is less than or equal to -20. I am going to substitute my ordered pair 0, 0 in for x and for y, and then I'm going to simplify. So 0 minus 0. Is 0 less than or equal to -20? The answer to that is false. So I will not shade towards 0, 0. So what that means is this half plane right here is false. That's not where the answers are. I have to shade in the opposite direction. So I have to shade away from 0, 0 because 0, 0 does not indicate a solution area. So I drew in my arrow. Now I'm going to grab my highlighter and I'm going to go ahead and highlight. So I'm going to highlight above the line. Again, being very careful so that my teacher can see that my line is a solid line and not a dotted line. All right, ladies and gentlemen, here's our last example. X is greater than or equal to 7. Hopefully you remember from the beginning of the school year when we graph vertical and horizontal lines. If you just have one variable, I strongly suggest that you use an XY table to graph. X is 7, so I'm going to plug in 3 7s for X. I put a -7 there on accident. So I have 3 7s, and then I'm going to select 3 values for Y. I typically do -2, 0, and 2, but you could do any 3 you like. From here, I'm going to go ahead and plot these 3 ordered pairs. So I'm going to find 7 on the x-axis, and I'm going to go down to -2 on the y. I'm going to go 7 on the x and stay there. 7 on the x and up 2 on the y-axis. Okay, I'm going to look at my inequality, which is a greater than or equal to. That tells me I need a solid line. Okay, my line's a little bit off. I see that. Hope you'll forgive me. I'm drawing some arrows. And then now I have to determine if I shade to the left or to the right of that line. So I'm going to use my test point, which is 0, 0, my favorite test point to use. Here's my verification, x. I'm going to see if x is greater than or equal to 7. I'm going to write my ordered pair here. Because this inequality only has an x, I just substitute my x value in. 0 is greater than 7, which is what I get for an inequality. That's false. So I will shade away from the ordered pair 0, 0, which means I shade on the opposite side of the line. So that, my friends, is my solution to x is greater than or equal to 7. All right, it's your turn. Jot these checkpoints into your notebook. Make sure you graph them. Think about what kind of line you need, solid or dotted. Think about what you need to do to shade, and think about all the work that you need to do to verify what side of the line you're going to shade on. So go ahead, press pause, complete these checkpoints, check in with your teacher to get your homework.